Russian attack helicopters are engineered as heavy, fast, heavily armed platforms designed to aggressively bank over a contested tree line and dominate the airspace. Welcome to our breakdown of Russia's advanced battle and combat helicopters. Subscribe to Global WarWatch Network for deep dive analysis into the engineering and strategy behind military aviation. Early Russian military doctrine relied heavily on the flying tank concept. While Western militaries typically separated transport and attack roles into different airframes, early Soviet designs merged heavy armor, high-volume firepower, and infantry transport capacity into single, massive gunships. Modern Russian aerospace doctrine has adapted. Today, operations rely on 4 distinct purpose-built battle and combat helicopters to execute specific missions. We'll break down the aerodynamic designs, their specific weapon systems, and tactical deployments of each platform. Analyzing the engineering of these individual airframes reveals exactly how Russia projects airborne combat power today. The Mi-35M is the definitive 21st century iteration of the classic Mi-24 airframe, re-engineered specifically for high-temperature and high-altitude combat environments. This animation shows the major structural changes from the legacy model. First, the transition to fixed landing gear reduces overall weight and improves energy absorption during hard landings. Second, the stub wings were shortened from 6 weapon stations down to 4, reducing aerodynamic drag. At the rear, an X-shaped composite tail rotor lowers the acoustic signature. The Mi-35M is armed with a chin-mounted NPPU-23 turret, housing a twin-barrel 23mm autocannon. It utilizes an upgraded electro-optical targeting system to deploy anti-tank guided missiles against armored targets. By trading top speed for superior resilience, the Mi-35M bridges the gap between a legacy assault transport and a modern precision strike platform. The Mi-28, designated Havoc by NATO, is a pure, dedicated attack helicopter built strictly for anti-armor operations. To achieve superior aerodynamic performance and a slimmer profile, the designers deliberately omitted the large infantry transport cabin found in the Hind series. The defensive engineering is extensive. The entire crew cabin is heavily armored and built to withstand direct impacts from 20mm shell fragments. This schematic highlights the mast-mounted millimeter wave radar positioned above the main rotors. This sensor array enables the crew to detect and track targets in all weather conditions, day or night. While lacking a troop cabin, the Mi-28 features a tiny, cramped rear fuselage compartment. This space is engineered strictly for combat search and rescue missions to quickly extract downed pilots. The Mi-28 demonstrates a clear operational trade-off, sacrificing infantry transport capacity to maximize pilot survivability and dedicated anti-tank lethality. The Ka-52 Alligator serves as Russia's premier reconnaissance, aerial command, and strike platform. This vector animation illustrates its core aerodynamic innovation, the use of coaxial, counter-rotating main rotors. 2 sets of blades spin in opposite directions, and the opposing torque forces cancel each other out. This torque cancellation entirely eliminates the need for a tail rotor. As a result, the aircraft is immune to crosswind yaw disturbances and maintains exceptional hovering stability. Because there is no tail rotor overhead to pose a strike risk during extraction, the airframe accommodates an extreme rarity in rotary-wing aviation, crew ejection seats. The Ka-52 carries a heavy offensive payload of up to 2,500 kilograms. This includes a 30mm Shapunov cannon and long-range Vikhar missiles. Bypassing conventional helicopter physics allowed engineers to build a platform that functions as the most agile and offensively capable node in the Russian airspace. The Mi-26, known as the Halo, is the logistical backbone of the fleet. It is the most powerful serial production helicopter in the world. It generates massive lift using 2 10,000-horsepower engines connected to an 8-blade main rotor. This 3D volumetric diagram compares the internal 12 by 3.2 meter cargo dimensions of the Mi-26 with the cargo hold of a C-130 Hercules transport plane, showing near parity in volume. The operational payload limit is 20,000 kilograms internally. That translates to 2 massive combat vehicles or up to 90 fully equipped paratroopers. The advanced strike fleet relies on the rapid force projection and heavy logistics provided by the Mi-28 to sustain high-intensity, deep penetration campaigns. The proliferation of modern air defense systems forced Russian doctrine to shift from aggressive deep penetration flights to defensive standoff operations. This tactical map shows the Ka-52 operating in a standoff role. The helicopter maintains a static hover safely outside the range of short-range air defenses, destroying advancing armor with long-range guided missiles. Conversely, the Mi-35M often utilizes a low-toss tactic. The pilot flies at treetop height, pitches up rapidly to fire unguided rockets like airborne artillery, and immediately dives back into cover. Advanced countermeasure systems, including dense deployments of defensive flares, are utilized continuously during these maneuvers to defeat heat-seeking anti-aircraft missiles. Structural engineering dictates tactical survival on the battlefield. The specific capabilities of each airframe determine exactly how and where it is placed in the modern battlespace. Despite their structural differences and separate roles, platforms like the Ka-52 and Mi-35M are increasingly unified by shared logistics and standardized components. This schematic illustrates the integration of the VK2500 turboshaft engine across both airframes, a standardization effort designed to streamline battlefield maintenance. The future trajectory of the fleet involves transforming these manned helicopters into aerial command posts that direct integrated swarms of uncrewed aerial vehicles. The lethality of the modern Russian rotary-wing fleet is derived from its ability to function as a tightly integrated, highly specialized tactical ecosystem. Thank you for watching. If you found this breakdown useful, please like, share, and subscribe to Global WarWatch Network. Let us know your thoughts in the comments, and check the description for our social media links.